In this video, we talk about two ideas, one being the idea of a relative extrema for a function, the other being the idea of a critical point or critical value of a function. All right. Let's start off with the idea of a relative maximum. A relative maximum is one kind of relative extremum, and here's the definition. F of x0 is a relative maximum for the function f if there exists an open interval I containing x0 such that f of x0 is greater than or equal to f of x for all x in the interval I. Let's take a look at an example of this. Okay, here I look at the value of f at 2 appears to be a relative maximum because notice there's an open interval containing 2, and on that open interval f2 is the largest value. If I go a little bit to the right, I get smaller values of f. If I go a little bit to the left, I get smaller values of f. Okay, and so this is the largest value in its vicinity, I sometimes say. And notice that relative maximum is some number slightly less than 6. Okay, remember it's the function value that's the relative maximum. Okay, in just loosely speaking, we can think of relative maximum as the height. Remember, it's the height, the function value, the y value of the top of a hill on a function, on the graph of a function, I should say. Relative minimum is the same idea, except that it's the smallest value in its vicinity. And let's take a look at an example of that. Okay. All right, notice that here is a relative minimum. Notice in this case, its smallest value. It looks like the relative minimum here is slightly less than 4. And if I go to the right, I'll get larger function values. If I go to the left, I'll get larger function values. Okay, and so this is the smallest value in its vicinity. All right, and remember again, the y value is the relative minimum. When we talk about relative maximum, the relative minima, all right, we're talking about the y value. The x0 is just the location that produced that value. So let me get rid of this. And loosely speaking, a relative minimum, again, is the height. It's the function value. It's the y value, all right, at the bottom of a valley. Okay. Now, a function can have more than one relative maximum and more than one relative minimum. And we have then another term, all right, and this is the term relative extrema. Okay, all right, and a relative extrema, f of x0 is a relative, if f of x0 is a relative maximum or a relative minimum, then f of x0 is called a relative extrema. So extremum or extrema, there's a plural, all right, is the catch-all that talks about either maxima or minima, okay, depending on what we might have. All right, now let's go on to talk about the idea of a critical point. The value x0 is said to be a critical point for f if it has to meet a couple of conditions. If x0, first of all, it has to be in the domain, and second, the first derivative either has to be 0 or the first derivative has to be undefined. The function is not differentiable at x0. So either the first derivative is 0 or undefined, then we have a critical point. So an example here, f of x is equal to x squared. If I look for the critical points here, well, I have to look at the derivative. The derivative of x squared is 2x. And now either this derivative could be 0 or undefined. Well, this 2x is never 0. So let's see, let's set it as never, I'm sorry, 2x is never undefined. So let's set it equal to 0. So we'd have x is equal to 0. And 0, x equals 0 makes this critical, this first derivative 0, so it's a critical point for f. So since f prime of 0 is equal to 0, since it makes the first derivative 0, all right, x equals 0 is a critical point for f of x equals x squared. Let's take a look at one more example. All right, let's look at this example. G of x is the cube root of x. Another way of representing the cube root of x is x to the 1/3 power. And so now remember the critical points are values of x that make the first derivative either 0 or undefined. So let's take a look at the first derivative. G prime of x is going to be 1/3 times x to the 1/3 minus 1, or 1/3 minus 3/3. 1/3 minus 3/3 is -2/3. And this is going to be the same thing as 1/3 times x to the 2/3. And x to the 2/3 is the cube root of x squared. So the derivative of g is 1/3 times the cube root of x squared. All right, now this g prime is never going to be 0, all right, because notice for a fraction to be 0, the numerator would have to be 0, and the numerator is 1, so it can't be 0. But if x is equal to 0, the denominator of g prime is 0, so that would make g prime undefined. So since g prime evaluated at 0 is undefined, x equals 0 is a critical point for g of x equals the cube root of x. Okay, so remember, critical values will either make the first derivative 0 or undefined. Now when the first derivative is 0, we have horizontal tangent lines. When the first derivative is undefined, we have, remember, one of those three things. We either have a break, a cusp, or a vertical tangent. So let's take a look at this. Notice that in this case, all right, the x values that I've marked either make f prime 0 or undefined. So notice here that we have the critical values at a, because f prime at a is 0, all right, we'd have a horizontal tangent there. At b, f prime of b is undefined. I'll just put a u here. At c, because f prime of c is also undefined. All right, at d, notice d, we have a vertical tangent, so f prime of d is undefined too. I guess I'm not going to have room for all of them. At e, we have a critical point because, again, we have the first derivative being 0. All right, it's horizontal tangent. And at f, we have the first derivative being 0 again. Okay, so at a, e, and f, the first derivative was 0. At b, c, and d, the first derivative was undefined. Notice we have a relative maximum at a. Maybe I should put r max and r min. At a, notice we have, and maybe I'm going to list these out a little bit more carefully. We had, of course, all of these are critical points: a, b, c, d, e, and f. All right, at a we have a relative max. At c we have a relative max. Both are the tops of hills. All right, at b we have a relative min. It's the bottom of a valley. And at e we have a relative min, the bottom of the valley. All right, notice something, that all relative extrema occur at critical points. All of these relative extreme values occurred at critical points, but not all critical values locate relative extrema. For example, here we had D and F. D and F are critical values, but they don't locate relative or relative maximum or relative minimum, either one. So we have to keep in mind here that we have here, let's consider this set B, or this set of this blue set, all right, the set of all critical points, okay? All right, within and properly contained within, this means there's some things outside of this, all right, properly contained within the set of critical points is the set of x values of relative extrema. Okay, so the idea that we're going to have here is that we're going to be looking for the relative extreme values, all right, and we'll start our search all right, by 1, we'll search for critical points. We search for critical points, and then 2, all right, 2, all right, once we found the critical points, we know that someplace among them are the x values of relative extrema. So then we have to, among these critical points, then we have to basically test the critical points, I'll abbreviate that CP, to see if they locate relative extrema. Okay, all right, and that's what we'll be doing in the rest of this section.